Hi everybody, it's Miss McClellan here to go over IM2 Notes 9.1.4 with you, transforming absolute value functions. Now I've already written our learning goals. They are 1. In the first person, I will be able to apply methods of transformations from parabolic functions. Basically, we're going to be using H, K, and A again to identify and describe effects of vertical and horizontal shifts, reflections, and stretches or compressions on absolute value functions. We're not really going to do reflections today, so let's just cross that one out. And number 2, given the graph of a transformed absolute value function, I will be able to write its equation and determine its key features, including x and y intercepts. Okay, we'll get right to it. This is a quick review of the absolute value function. So we consider these function machines and we take note of what they're doing. In this first one, when -9 goes in, +9 comes out. When +7 goes in, +7 comes out. When square root 2 goes in, square root 2 comes out. And when negative square root 2 goes in, positive square root 2 goes out. Let's see if we can describe this. So, what goes in if 4 goes out? Well, 4 could be one of the inputs. But -4 would also produce +4 because if I'm following the same pattern, -9 produced +9, so -4 should produce +4. +7 produced +7, so +4 should produce +4. Okay, what happens if -16 is the input? Well, +16 will be the output. What happens if +16 is the input? Well, then +16 will be the output. What happens if -3 is the output? Impossible. Absolute value only returns positive numbers. And there's no hidden imaginary numbers in this situation. Absolute value only returns positive numbers, period. If we're given an output for this machine, we can figure out the input. Well, if we're given an output, we can figure out the input by making the output both negative and positive. For example, if the output is 4, then the input could be 4 or -4. All right, we're going to make a graph of this function. So we're going to make a graph of the function f of x equals the absolute value of x. And I'll do this by making a t-table. So when x is -1, y is +1. When x is -2, y is +2. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. Let's plot those. X is -1, y is +1. -2, y is +2. 0, 0. Over 1, up 1. Over 1, up 2. There's my graph. The domain. There are no restrictions on x, x can be all real numbers. Now, depending on who you had as a teacher in earlier math classes, there's a couple of ways that this might be written. You might have this written as negative infinity is less than x is less than positive infinity. You might have this written as open parenthesis, negative infinity, comma, infinity, close parenthesis. The range. Y must be greater or equal to 0. Again, you may have this written in a couple of ways. This could be written as y is greater than or equal to 0, or as close bracket 0, comma, infinity, open bracket. Close bracket is when equality is included. Open bracket is when equality is not included. Appearance, it looks like the letter V. Period. Let's continue. Transformation, team challenge. We're going to match each equation, and there are several, to its type of transformation. For problems with coordinate planes, we'll graph the function. What's that mean? Not every problem is requiring a graph. Okay, I'm going to start with my parabola problems because I know how to do this. So for example, I know that this shifts left 3. And on the left I have absolute value and on the right I have parabola. So I'm going to find something that says shifts left. And that's y equals x plus 3 squared. Now, let's see. I also have an analogous absolute value problem. Y is the absolute value of x plus 3. Write that in. Oops. This would also go left 3. Okay, let's do another one that I know how to do. I see this one. This goes right 2. This is a parabola that shifts right 2. Y equals x minus 2 squared. And for my absolute value version, I'm noticing that each has both versions. Yes, I have y is the absolute value of x minus 2. I guess I'll graph both of these since I'm required to. Okay. I'm going to use my step function for the parabola. A is 1, so my step will be 1, 3, 5. Starting with the vertex at x is 2, so vertex is at 2, 0. I'll use my step function. I go right 1, up 1, right 1, up 3, right 1, up 5. And then I mirror that. And I connect with a smooth curve. Smooth as I can make it. Okay, now I'll do my vertex. I mean my absolute value. Well, absolute values and parabolas have some things in common. First of all, they each have a vertex. So vertex here is going to be at 2, 0. And they each have a line of symmetry. Meaning I can construct the graph of this absolute value function by doing one side of the graph and then by mirroring that, just like I did with my step for the parabola. So I see that A is 1 because A is still in front of how x shifts, which means my slope is 1. An absolute value is a line taking off from the vertex and then mirrored. Anyway, I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Absolute values have constant slopes on either side of their vertex. The absolute value graph is why we always try to reinforce that parabolas need to be graphed with a smooth curve so that they don't look like absolute value graphs. Let's do another. Okay, let's do one where the slope is not 1. I think I can find one like that. Okay, yeah, here we go. So we'll do these two. 2x squared and 2 times the absolute value of x. This is a vertical stretch. We don't have to graph those. Y equals 2x squared for my parabola. Y equals 2 times the absolute value of x for my absolute value function. Let's do another. Good. This has a is not 1. That's a good example. Okay, 0.5. Y equals 0.5 x squared. This is called a compression. It means that the graph is squished downward. So if I was like this, gets squished, and I end up like this. Anyway, here I have my vertex is at 0, 0, since h and k are both 0. A is 0.5, so my step function is going to be 0.5 times 135, which is 0.5, 1.5, 2.5 for my step. Okay, so I go over 1, up 1/2, which isn't very easy for me to do unless I adjust the scale of my graph. So I'm going to define every other tick as a full piece. So this will be 1, this will be 2, this will be 3, this will be 4. Okay, here I go. So I go over 1, up 1/2. Then I go over 1, up 1.5. Then I go over 1, up 2.5. And that's going to be my graph. And I'll mirror it. Okay. Trying to make sure it doesn't look like an absolute value pointy graph. Smooth curve. Okay. My analogous absolute value function is y equals 0.5 times the absolute value of x. And that has a vertex at 0, 0, since h and k are both 0. A is equal to 0.5, so my slope is 0.5. And again, I think I'm going to count every other lattice as an interval of 1. Okay, 1, 2, 3. Just to make this easier to graph. Okay, so I have a point at 1. I go over 1, up 1/2, because my slope is 1/2. But I do that same slope every time, because it says in a parabola, this is an absolute value function, which is essentially two lines coming together, mirrored about their vertex. There we go. Okay. Let's put our parent functions in. Here they are. For my absolute value function, the parent is y equals the absolute value of x. This is the graph from which all other graphs are transformed. Y equals x squared is the parent of the parabola. For my absolute value function, A is equal to 1, and the vertex is at 0, 0. So go from 0, 0, up 1 over 1, 1 over 1. There we go. And I'll do the same thing on the other side of the vertex. And that's that. And then for y equals x squared, my vertex is at 0, 0. My step pattern is 1, 3, 5. So I start at 0, 0. I go over 1, up 1, over 1, up 3, over 1, up 5. 1, 2, 3, 4, 5. And then I mirror those points. And I try to make sure it doesn't look like a absolute value function. Taking care to make the bottom in particular look smooth and curved. Okay, what's next? Let's do vertical shifts. Let's do the shift that goes up 4. Where are they going to ask us for that? Shift right, shift left. Shift up, yay, okay. So my shift up for my parabola is y equals x squared plus 4. And for my absolute value, it's y equals the absolute value of x plus 4. Okay, my vertex is at 0, since h is 0, comma 4. And my step is 1, 3, 5. I start at 0, comma 4. I go over 1, up 1, over 1, up 3. And that's all I have space for. Mirror those points on the other side of my vertex. There. Okay, and then for the absolute value function, my vertex is at 0, comma 4 again, and my a is equal to 1, so my slope is 1. 1, 2, 3, 4 for my vertex. I go over 1, up 1, 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 over 1, up 1. Connect. And I mirror that on the other side. Let's do my shift down next. Looks like I only have to write the equation for that. Shift down minus 5. Okay, so shift down, that's going to be y is the absolute value of x minus 5, and y is equal to x squared minus 5. That would have shifted my graphs down. Looks like I only have one left. It's going to be the graph that opens down. Okay. For my parabola, I have y is negative x squared. And for my absolute value function, I have y is the absolute value of x with a negative out front. If it were inside, if the negative were inside, it wouldn't have any impact because absolute value would just turn it positive. So it's important to notice that the negative is out in front of the absolute value bars. Okay, so for my parabola, my vertex is at 0, 0, since h and k are both 0. So 0, 0 is my vertex. And a is equal to negative 1. That's the coefficient of x squared. So my step pattern is going to be negative 1 times 1, and then 3, and then 5. So my step pattern is negative 1, negative 3, negative 5. Okay, starting at 0, 0, and going right 1, down 1. Right 1, down 3, right 1, down 5. Okay. And then I connect these points with a smooth curve best I can. And I mirror that on the other side of my graph. Smooth, smooth, smooth. Cool. Let's do the absolute value. 0, 0 is my vertex again. And my a value is -1, so my slope is -1. So I start at my vertex, and I go right 1, and then I go down 1, since that's a negative slope. Right 1, down 1, right 1, down 1, right 1, down 1, etc. Okay. And I'll do mirror that on the other side. So the main difference between the parabola and the absolute value is that the parabola does not have a constant slope, whereas the absolute value does. Let's summarize what we've done. So the graphing form of the equation for the family of absolute value functions is y equals a times the absolute value of x minus h plus k. And we're going to try to figure out the equation from this graph. So first thing I notice is that my vertex is at 1, 2. So I'm going to have x minus 1, absolute value of that, and then plus 2. And then I just need to figure out what a is. What's a? First of all, I know it's negative because the graph opens down. So opens down, so a is negative. And then I notice the slope is over 1 right 1 down 2, which means the slope would be -2 over 1 because we have change in y over change in x. So that's what a equals. So my equation is y equals -2 times the absolute value of x minus 1 plus 2. A causes the graph to open down and sets the slope as -2 for the side to the right of the vertex. On the left-hand side of the vertex, the slope is +2. That's why it's important to say that you're going to the right of the vertex. Okay, h causes the graph to shift right 1 unit. And k causes the graph to shift up 2 units. Okay. I continue. This is 9-40. Without graphing, we're going to determine the x and y intercepts of the function g of x equals 4/5 times the absolute value of x minus 2 minus 2. And then we're going to sketch the graph and label its important points. So let's start out here. Okay. So to find the y-intercept, I set x equal to 0 and solve for y, which gets me 4/5 times -2. 0 minus 2 is -2 minus 2. Sorry, the absolute value of that one, of -2 for the first part. So this becomes 4/5 times positive 2 and then subtract 2, which is equal to 8/5 minus 10/5, which is negative 2/5. So my y-intercept is at 0, negative 2/5. And if you put that in your calculator, that's negative 0.4. For the vertex, I have a vertex at positive 2, negative 2. That's just from HK. In my equation, this is H and this is K. Okay, and my x-intercepts, that's a little bit harder because I have to solve an absolute value equation. So going to set y equal to 0 and solve for x. So I'm going to have 0 equals 4/5 times the absolute value of x minus 2 minus 2. I'll start by adding 2 to both sides, but I'm going to do it over here. So I have 2 equals 4/5 times the absolute value of x minus 2. I'll multiply both sides by 5. That gets me 10 is 4 times the absolute value of x minus 2. I'll divide both sides by 4. That gets me 2.5 is equal to the absolute value of x minus 2. Now, if 2.5 were equal to the absolute value of x, then I would have x could be either positive or negative 2.5. But I've got this shifted. So let's say this is x. So if 2.5 were equal to the absolute value of just x, then x would be positive or negative 2.5. But that's not the case. 2.5 is equal to the absolute value of x minus 2. And this makes it just a little bit more interesting. So if I were solving a quadratic equation and I were doing it by taking the square root of both sides, I would take the square root of both sides and then I would use both the positive and negative versions of the square root of 2.5. But that's not what I'm doing, except it's very similar. I can undo this absolute value simply by creating the following two equations. Positive 2.5 equals what's inside the absolute value, so positive 2.5 equals x minus 2, or negative 2.5 equals what's inside the absolute value, so negative 2.5 equals x minus 2. To each equation, I add 2 to both sides. The top one gets me x is 4, and the bottom one gets me x is 0.5. Sorry, the top one should have given me 4.5. That was a mistake on my part. So I have my x-intercepts at 4.5 and 0.5. Now we're going to graph this to check our answers. And I see a lot of 0.5s going on, so I'm going to count every other lattice for my x scale. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I only really see positive values for most of my stuff, so negative. So I'm not gonna worry about labeling the left-hand side of my x-axis. -2, -3, -4, 5. Okay, I'll start with my vertex. My vertex is at 2, -2, so I'll plot that over 2, down 2. I know I'm going to open up, so I'll label this below. And A is equal to 4/5, so my slope is 4/5, so I could go over 1 up 4/5, or I could go over 1 up 4/5, or I could go over 5 up 4, and that's what I'm going to do. Aha! Graphing is so cool because sometimes it helps you find your mistakes. I had some algebra mistakes with negative numbers. Let me show you. So this should have been -0.5, and I noticed that mistake that I made while I was graphing. This line goes through my graph at -0.5. Okay, and this one was correct. 0, 4.5. Oops. Should be 4.5, comma 0. 4.5, comma 0. And then my y-intercept is very close to 0.5, and that's good because -0.4 is very close to 0.5. So I'll label that as well. 0, comma, -0.4. It's this point right here. Okay, we continue. Okay, to graph quadratic functions in the form y equals a x minus h squared plus k, the first step is to identify the vertex and a values. Then you'll plot the vertex, which is at hk. Then, starting with the vertex, you plot points to the right using your step pattern, to the right of the vertex. And then to the right of the vertex, the step pattern is a times 1, 3, 5. When a is 1, you have a short, you can just do 1, 3, 5. But if a is not 1, you'll have to figure out what the step pattern is. And graphing absolute value functions is almost the same. First, you identify the vertex and a value. Then you plot the vertex at hk. Then, starting with the vertex, you plot points to the right using the slope. And to the right of the vertex, the slope is just equal to a. So you go over 1, up a or down a, depending on whether or not a is positive or negative. Then you use symmetry to draw the other side of your absolute value function. And that's it. That's the end of these notes. The main takeaway is how to graph the absolute value functions, but you should also be able to do example 939, where you had to find the equation, which is essentially you have the vertex and then you can solve for a by checking on what the slope is to the right of the vertex. Okay, have a great day. I'll see you next time. Bye!